thank you everyone for coming to our final day of press conferences. This is the first press conference of the day, and it's on earthquake precursors. I would like to remind everyone in the room, sorry for those who have been coming to all the press conferences and are tired of listening to me say this. There will be short presentations by our panelists, and then we'll open the floor for questions from those here in the room. We'll give priority to journalists. And then we will also move to those watching us remotely who can ask questions on Skype by messaging EGU.media or on Twitter by using the hashtag AskEGU. So I'll now introduce our panelist speakers. Sergei Polinets is the principal scientific researcher at the Space Research Institute at the Russian Academy of Sciences in Moscow. Pietro Milito is a PhD student at the School of Engineering, University of Basilicata in Italy. Gabriel Berberic is a researcher at the Faculty of Biology Geology at the University of Duisburg-Essen in Essen, Germany. And Max Wiss is the director of the World Agency of Planetary Monitoring and Earthquake Risk Reduction, and is an expert on evaluating proposed earthquake precursors. Thank you. You can now start.
Okay. Good morning. My name is Sergei Polinets, and probably the title of my presentation is too aggressive, but I would like to demonstrate you that the progress of our research, and our research are based on the, common sense and physics. In this graph, you can see the comparison. In the left, it is earthquakes with different magnitudes, and to the right, different natural and anthropogenic events. And you can see that the energy released during the strong seismic events is comparable with nuclear bomb explosions of higher energy equivalent. So physically, it is impossible that nothing happens before earthquakes. We have deformation stored in the Earth's crust. This changes the properties of the Earth's crust, and in the 70s and 80s, there were researchers measuring the changes of the conductivity of the crust, gas emissions, gravity anomalies, changes of seismic waves, velocities, and so on. And our work has roots on the works of Christopher Scholz et al. His paper on physical precursors of earthquake is published in 1979. And what we are doing, we are continuing this work, but moving up from the ground surface into the atmosphere and near space. And for this, we use the satellite technology. What is the advantage of the satellite technology? If you look on these images, you cannot say, what is this? There are some spots. One are yellow, one white, one red, one black. But if we start to look from the satellite, we see the real image. The satellite technology integrate the data over the large territory. The fail of the early short-term predictions was based on the fact that they were single-point measurements. And for example, if you measure radon, you have a sensor in one place, but radon comes out 100 meters apart. You do not see anything in this point. But from the satellite, we integrate all over the area of the earthquake preparation. So, and we are able to also create some portrait or image or what we name the mask of the precursor. They have self-similarity in the given region, they appear more or less at the same local time, and we use this self-similarity analyzing historical earthquakes. This is a mask created from analysis of M6 earthquakes in Greece during 12 years. And we can see in the vertical axis it is a local time, in the horizontal axis is a days before and after earthquake, and arrows shows the moment of the earthquake. And what you see in red, we see that positive anomaly in the ionosphere appears, and 4 p.m. day before the earthquake, it continues to the 4 a.m. next day. And we started to think if it works in general in other parts of Europe. And here you can see the similar examples. The top left, it is Sochi in the Black Sea, quite recent earthquake. Again, you can see the similar pattern. The top right, it is a Van earthquake in Turkey. Again, you can see the similar pattern. And here in the bottom, the multiple patterns, it is almost the months of observation before the Aquila earthquake. Okay, but it is only one parameter. If we come to medicine, you cannot put diagnosis measuring only temperature. You have high temperature, you may say that you have a disease, but it is tuberculosis, grippe, or hepatitis. You need to make the multiple parameters analysis. You have analysis of the blood, screening, ultrasound, and so on. So we are studying the process as a complex process. Every square on this diagram, it is some physical parameter. So what we are saying, that prediction is possible when you combine many parameters, not only one. Okay, every of them could appear without earthquake, but this complex is possible only when earthquake is coming. And this is a demonstration, for example, for Colima earthquake. From top to right, and you see the ground temperature anomaly over Colima, the anomalous fluxes of the latent heat in atmosphere, then outgoing long-wave radiation, infrared, measured on the top of the clouds by infrared sensors installed on both satellite. And last one, color picture, bottom right, it is an ionospheric anomaly. So here, at least 4 parameters we are able to detect. We select the key parameters which appears always in all types of the earthquakes. And we can calibrate the magnitude using the Dobrovolsky and Bowman approach, estimated the earthquake activation area. You see ground surface anomaly before the Aquila earthquake. We select the integrated parameters which give you the time of the earthquake. Usually we see statistically the precursors appear in 5 days before the earthquake. And we can, from satellite images, to determine the approximate earthquake epicenter position. This, again, Aquila left is infrared, right, it is ionosphere, and we are doing in real time. This is, again, Greece, and in the right corner, you see the last 2 earthquakes happened in Crete and southern Greece on 6th and 9th of April. So we were here, and we were able to monitor and see the precursors of this earthquake. And this is the last picture. It is the precursors of the precursor. It is integrated parameter we use. It's temporal dynamic before the recent earthquake in Iran, which happens on 9th of April this year. So again, we were here, but we were able to analyze the data. And you see that it appears 5 days before the earthquake. Thank you very much.
Thank you, Pietro.
Okay. Welcome. I'm Pietro Melillo from University of Basilicata, and today I will introduce my work about variation of altitude observed on the occasion of the Tohoku earthquake. Okay. This study starts at University of Bari within the Professor Biagi group at Physics Department. First, I will introduce the context in which my work is collocated, and I will show a quick review of the 2002 earthquake precursors, and then my GPS altitude anomalies. So, earthquake precursors can be divided in middle-term precursors and short-term precursors, and it is important to underline the fact that different group of study, different research group reveal the possibility of middle-term and short-term precursors using different instruments and techniques. Short-term anomalies concern positive GPS total electron content in ionospheres, and these anomalies are well documented by Professor Eiki for Hokkaido University. Middle precursors consist in VLF and GPS anomalies, and now I will introduce my work on GPS altitude anomalies. So, in this study, we analyzed GPS height and what happened. We analyzed GPS height measurements, and they show an evident decrease in the altitude appeared from the beginning of the march. The talk earthquake occurred in the 11th March, and in order to investigate in detail the possibility, we analyzed the GPS daily data collected during the 2011. This data comes from the GSE, which is the Geospatial Information Authority, which handle the data and sell us to researchers. And this is the nationwide GPS array of Japan and consists of 1,240 stations. Preliminary results of the analysis show 4 different behaviors, and in particular 10 days before the earthquake, some possible anomalous variation appeared. This behavior was revealed in several stations of the network located in the epicenter area. We performed an Aurea analysis. In order to confirm this daily behavior, and these are the results. We choose, of course, a subnet of the stations, and we use a sliding window technique. What we can see on the right side are the results of this analysis, just 2 stations. And while on the left side, we can see the chosen subnet. Okay. An anomalous pre-seismic falling was confirmed by hourly analysis, and in this graph we can see in blue the daily data from GSI, while in red hourly data. On the x-axis we have the hour starting from the January 1st, 2011, while on the ordinate axis we have the pre-seismic height. Performing hourly analysis gave statistical evidence to our measurements, and both data confirmed the same decline rate of minus 29.3 centimeter per year, while hourly analysis reduced standard deviation, so our velocity error. Okay, this is a complementary study that we made with the Italian Space Agency. We performed a persistent scatter analysis within Cosmos SkyMed data, and these data were made available by the Italian Space Agency. Persistent scatter analysis is the most advanced of the differential interferometric synthetic aperture radar techniques. And this technique is based on a multi-temporal image processing method, which is able to detect an millimetric terrain motion phenomenon, useful to validate and extend GPS measurement, because GPS is a punctual information, gives a punctual information, while persistent scatter could give more information on urban area. Unfortunately, we did not have data before the earthquake, so we use this in order to validate our GPS data. And this is a future work that we are able to do on Italy with the MAP Italy project from Italian Space Agency and the INFREP network from Professor Biagi. Thank you.
Good morning. My name is Gabriele Berberich from the University of Duisburg-Essen, and we do a quite different approach. We use a geobioscience approach to take the advantage of both biology and geology, and we try to figure out whether redwood ants show unusual behavior prior to earthquakes. And the question is, why redwood ants? Because redwood ants, as you can see top here, they are living on top of tectonic active fault zones. They have developed chemoreceptors for the CO2 detection and detection of CO2 gradients, and they have developed magnetoreceptors for the detection of electromagnetic fields. So in monitoring those ants, we do an important step forward towards the understanding of geobiological processes and diagnostic precursors. And for this, we have developed an automated image evaluation routine in cooperation with our colleagues from the TU Technical University of Dortmund, and to objectively identify and classify the ants' behavior on top of the mounds, and to examine the ants' activity in comparison and correlation with earthquakes. And our first findings are that redwood ants show unusual activity or bioanomalies, as we call them, prior to earthquakes with a magnitude larger than 2. But they don't show any significant bioanomalies prior to earthquakes with a magnitude lower than 2. So we are not sure at the moment how and why they react prior to these earthquakes. And we have a hypothesis, because possible stimuli can be the emanation of gases and chemical or toxic substances, as we have found out in another project, for example, benzene, xylene, and toluene. This is also documented on our poster EGU2013 tonight. And due to stress variations during the earthquake or depressurizations. And another possible stimuli can be changing of electromagnetic fields on top of this fault zone. So we are aware that earthquakes with a magnitude of 2 or 3 is not that big, and we are planning to go to more tectonically active regions in the next year to show and to figure out whether the ants show similar or different reactions. So this is a schematic sketch to show you how we think about this and the theory behind. And as you can see here, if the open and tectonically active fault is running open for a long kilometer distance, then you find a linear alignment of the redwood ant mounds on top of it. And if you have intersections, you find clusters. And this is how it looks like in the field. You go through the forest and you find a lot of ants, for example, 120 mounds in a line on a tectonic open fault. And we installed monitoring systems, 2 of them, as we call them ant camps, in the Lacher See region. Probably you know about this because the Lacher See volcano is one of the last eruptions in Germany. And from 2009 to 2012, we recorded 24 hours, 7 days a week, the ants' activity on top of the nest. As you can see here, these are both nests. Pictures from our camps during the days, and we use high-resolution cameras with color and infrared sensors to monitor also the activity at night. And up to now, we collect more than 45,000 hours of video streams, which we have to evaluate. And as you can imagine, we can't do that manually, so we developed the automatic image analysis system, which is based on different images. And then we correlate our results with local earthquakes and earth tides and meteorological parameters and biological parameters. So what we found out what was done before in biology is that ants have a daily routine, as we have as humans. That means they rest at night and they have activity phase at the daytime. And we call this, as you can see on top left, as an M-shaped curve. This is a very identifiable standard daily routine. And the question was, how would the ants react if there would be an earthquake? And we were very happy to have an earthquake on the 10th of September 2009. And you can show here there are anomalies in their reaction. They don't go to sleep, or they don't have the rest phase at night and at daytime, and they resume their standard daily routine only the day after the earthquake. And if the earthquakes are lower than magnitude 2, we don't have any significant reaction. So we are hoping to get new results in a more earthquake-prone area. Thank you.
My name is Max Ruiz. I have been chairman of the IASPE, that is International Seismology Association, of the subcommission on earthquake prediction for something like a dozen years in the past. And I have spent quite a part of my life to search for precursors. And that's why I'm very happy that we have a conference here on the topic of earthquake prediction. The solution to this problem would be the most important problem to solve in seismology and to help society. But at the present, there are no big programs, no big funding, and there's very little done. Also, there are few reports at this conference. So I am very sorry to see that we have not made much progress in the last several decades. And I think that for the lack of funding and the retreat of young scientists into the ivory tower and not exposing themselves to criticism studying earthquake prediction, those two factors are due in part to exaggerated claims in the past of success that then were not realized, and by enthusiastic researchers who did not do careful work, and also in part by sensationalist reporting of things that were actually not true or were exaggerated. Like I could tell you afterwards a few examples why I am examples of what I have experienced and why I am very pessimistic, and hope that we can come out of this low in interest on the professional level in earthquake prediction. One of the problems is that for some people who wish to help mankind, earthquake prediction, the wish of earthquake prediction, becomes something like a religion. You believe in it or you don't believe in it. There are believers and non-believers. And the believers cannot be dissuaded from their quest of proving what is in their head, on proving that this happens in the world. Even when the evidence is incredibly much against it. And this is very regrettable. It has done a lot of damage to our reputation in seismology and the funding. Let me tell you a quick anecdote, facts. I participated in a meeting in China. It was a meeting on earthquake prediction. It had all kinds of elements in it, including animal behavior. There was a zoology professor from Italy who said, in his talk, showed evidence that the snakes, the vipers, have left Friuli before the Friuli earthquake. Friuli is a province of northern Italy, northeast, and the earthquakes have killed about 2,000 people. It's a very serious event. And this zoologist claimed the snakes, the vipers, have left the area because they knew the earthquake was coming. And after the conference, after his presentation, I asked him, well, how did you have the data that you showed on a graph of decreasing counts of vipers and then the earthquake? He said, well, there was a program of the Italian government that paid so much money to each person who brought a dead viper to the police station because they wanted to eradicate vipers. I had the nerve to say to him, yeah, but sir, would you consider the possibility that the Italian program to eradicate vipers actually had an effect and was successful? And this was the reason. And he said, Italian government projects, I'm sorry, I'm not saying this. This man said it. And he is from Italy.
I work in another sector. So.
They have never success. That was the end of our conversation. Okay, I don't think I need to say any more. Another quick background of what disappointed me very much is that Greece has become the graveyard of precursory electrical signals. A physicist claimed that, and published on it, that he can predict every earthquake larger than magnitude 2.7 in Greece with an instrument, electromagnetic instrument that he had in his background in the suburb of Athens. Greece has dimensions of 1,000 kilometers, earthquakes of 2.6. To predict them from 1 point is already quite astonishing, to say the least, claim. Then I asked him to show me how he defines his signals. I was at his house, where this was his laboratory, and he showed me a strip of paper that was extremely long on a roll, and rolled it out and looked down by eyeballing, said, there is an anomaly. Then he published this paper, and I took the most important figure of it and analyze it. The figure was correlation of electrical signals and earthquakes. 1-to-1, each electrical signal had an earthquake, and it was 7 hours before the earthquake. So he can predict any earthquake. So at the bottom of this figure, it said that the list of earthquakes was from the National Observatory. I took the National Observatory catalog and discovered that 20 to 25% of the earthquakes that were in the catalog were not in his figure. 20 to 25%, I forget the exact number. Again, I've published this paper. What I'm telling you is published, and you can, it's been reviewed, and these are facts. 20 to 25% of the earthquakes that were on the figure were not in the bulletin. And I asked him about this, and he said, yeah, well, I had the seismograph in the backyard, and there were signals. Yeah, probably trucks going in front of his house. In addition, there was one earthquake that was in the bulletin of the observatory, and it was predicted by one of his signals, and it happened to be an earthquake of magnitude 7.2 in Japan. So now you can see that from my experience, I have become very skeptical. And this is very sad for me, because I would like to see progress in solving this problem of earthquake prediction. So what do we need to move towards solving this problem? We would like to have funds, but before we get funds to do it, we have to re-establish belief in the idea that we could actually reach that topic, and we have to see excellent work that would lead us to that, and we have to find a new commitment to do it. So I think that one thing one could do would be to fund, first of all, with small money, evaluations like this. This is the book where we had evaluations of claims, of predictions or precursors. I think if one would fund workshops to get to the bottom of some methods that are being proposed and evaluate, is this a usable thing? Can we, yes or no, invest in this direction of going? And if a fairly large group of seismologists would be able to identify directions to go, that would be great. And another example of how sad it is that funding has dried up is the German project on the North Anatolian Fault. There used to be a project of multidisciplinary different measurements being made, and it went for a decade or so. Maybe one of the German colleagues can say how long it went. And now it's dead. It was stopped, and of course, the problem is we don't have enough background of measurements to then know what an anomaly is. So I think we have to almost start up by our bootstraps again and evaluate the chances of where would it be good to invest money in this problem, and then invest it and do the research, but carefully. Thank you.
Thank you. Would anyone have any questions?
Can I just pick you up, Max? First, it's Jonathan Amos, BBC News. Are there areas where you think there are that are showing promise, that are worth looking deeper into? Which are the areas that you think are showing promise?
Yeah, in this book we have a list of methods or case histories that passed at least to a preliminary list of hopeful methods. And one hopeful, in my opinion, is seismicity patterns. Seismicity patterns meaning if we could finally understand how to discriminate foreshocks from an earthquake swarm that is not followed by a main shock. If we could solve that problem, that would be fantastic. Other patterns also, seismicity patterns of various sorts. That a little too technical to all mention now. Another case we have is crustal deformation. And crustal deformation that precedes and is anomalous is something that is very plausible. You know, to be interested in a technique to work, one has to have a hypothesis, first of all, right? And to be interested in a hypothesis, it has to be somewhat plausible. Although, if I cannot imagine this would work, that doesn't rule it out, right? I could not have enough imagination power. But many people think, because it's a deformational process that will happen, that there should be that should be measurable at the surface of the crust. And another one is groundwater. Groundwater chemistry, and also its level. See, because the Earth is a sponge, at least the crust of the Earth is a sponge with holes in it and there's water in it, and if you squeeze it then the water comes up in a well, for example. And also the chemistry. There are some cases that were pretty convincing in the past, but now the German program, for just one example out of many, has been terminated. They've been measuring these parameters and now they've been sent home because the funding agencies were getting tired to fund something that didn't have spectacular results and is waiting for decades.
Thank you. Are there any other questions?
Kate Rebellious, freelance. This is a question for Gabrielle. With the ants, what are your feelings about why they're reacting? What for them, what is the danger? And why are they reacting when it's greater than magnitude 2?
Well, we assume that they react to degassing, strongly degassing out of the tectonic faults, because we have pressure, we have strain on the faults during earthquakes, and that can change the gas structure within this fault. And ants are very sensitive to CO2 degassing. And they can detect, as I mentioned before, gradients, very tiny gradients. And so that would be one chance. And also they react to electromagnetic changes. That would be the second chance. And we are going to set up a big interdisciplinary project next year to figure out what in detail poses the ants or forces the ants to react in such a way. Because what we observe is the whole colony, nearly the whole colony except the queen, which is sitting very deeply in the nest, they are on top of the nest and we're really in an activity phase, which is quite unusual as biologists admit at the moment, because they have to stay in the nest, because they have a lot of predators coming at night and grabbing into the nest and eating ants, so it would be more safe for them to stay in the nest. And this behavior is totally unusual.
Does the earthquake present a danger to them?
Yeah.
So it could destroy the nest or something?
Well, it can destroy the atmosphere in the nest. Yeah. That's our hypothesis, yes.
Thank you.
I thought that was a good question. Can an animal that is proposed as being able to predict earthquake, what is the danger? How did it learn over its history? And so, just to mention another source of disappointment for me, Chinese have always claimed birds are reacting before earthquakes. Excuse me, birds are in the air most of the time. And how can they know about earthquakes? And if they are perched, they take to their wings, and the plausibility in that case is extremely low for me.
Well, I done mapping all over Germany, and I map more than 15,000 nests, and we do statistical correlation with tectonic faults, and there are matches very well. So we have very good proof and evidence that redwood ants are buyer indicators for tectonic active faults. I don't think you've heard in the US, but because last year I did a talk in Tennessee and I presented this, and also colleagues from Harvard University, they were very convinced, and they are doing this approach now in their field campaign. So you can't do this and step it aside and say, oh, it's disappointing. No, it's a new approach, and I think as scientists, you have to not to have the tunnel vision, but to have a broader sense and to try to work interdisciplinary.
I think Max and Gabrielle can continue the question later. There's just a short comment from a researcher in Germany here.
I'm sorry, but I would also invite the professor about, they say that they do not have funds for German fault, and I would invite you to work and be interested in the Italian project and the Italian collaboration between Italian Space Agency, University of Basilicata.
Again, sorry, Pietro, this is an event for journalists to ask questions, so please keep the scientific discussions for later. Please be very brief.
Okay, I've got actually read two very short comments. The first one is that several plate boundary observatories are being operated from Germany and in Chile and in Turkey, actually, again, by the US. Of course, Japan, the whole of Japan is a large plate observatory. The second very quick comment is that people also live where faults are, so people are very good indicators of tectonic activity, but it doesn't mean that they can predict earthquakes.
Okay, sorry. Okay. Questions from journalists, please. Are there any more from those here in the room? Or those watching us? Okay.
Sergei, could you just list what your parameters are that you're using? I didn't get them all. Which are the? So you're using several parameters that you're looking at, and the ionospheric disturbance. I mean, with Pietro here as well. What is the mechanism that you would get a signal in the ionosphere?
The first one, how many parameters? What parameters? Yes. In the moment, the most reliable parameter, it is outgoing long-wave radiation. It is infrared emission, which is measured from satellite on the top of the clouds. And second one, it is ionospheric variations. So the mechanism is following. When radon is escaping from the active tectonic faults and its activity grows rapidly, it produces by alpha emission ionization of the low layer of atmosphere. And these ions become the very good centers of water vapor condensation. We have the same process, as you probably heard, make the galactic cosmic rays forming the cloud coverage of our planet. It is absolutely the same process. And during this process, the large ion clusters are formed in the boundary layer of atmosphere, which replace the light ions and drastically reduce the conductivity of atmosphere. And we know that this is a global electric circuit. We have potential difference between the ionosphere and ground. So, and this happens on the huge territories. This is thousands of square kilometers. So, abrupt growth of the potential of the ionosphere in relation to the ground creates the anomalies in the ionosphere, which could be measured. Different techniques, ground-based vertical sounding, GPS total tech, total electron content, local probes on board the satellite. We had Demeter satellite during 6 years, continuous observations. The GPS receivers put on the satellites, and this they measure the total electron content. For example, we have the Taiwanese American space constellation from 6 satellite Cosmic, And they are able to produce a three-dimensional picture of the ionosphere. They perfectly see all these anomalies. So there are plenty of different techniques, and it is one more proof. All of them show the same, these anomalies. So these are two types, but actually we use many parameters. For example, you have Valerio Tramutoli to the right from you, who measures the ground surface temperature anomalies, again from onboard the satellite. We use the meteorological parameters, because when you have condensation of water vapor on ions, you will see the decrease of relative humidity, and we see for every earthquake this decrease. For Tohoku, now Iran, and so on. Decrease of the relative humidity, increase of air temperature. But of course it is variable parameter, we use it like indicator. And one more parameter, it is so-called linear cloud structures. Because you change the electric properties of the air, they have formed the electric fields along the active tectonic faults. And over these tectonic faults, you will see the formation of clouds, or reverse, in the cloudiness, you will see transparent line exactly over tectonic faults. And these phenomena are indicators of increase of tectonic activity. So all this complex of parameters we use.
Just a slight follow-up. I mean, an earthquake is a classic nonlinear system. I mean, you could get all of these precursors, and it doesn't go. So what, I mean, it's a general question to you. What level of accuracy in prediction do you need, given that if you give an alert, we've seen in L'Aquila what happened there, where scientists were taken in and put in court. You know, you could evacuate an area, you could have a road crash. I mean, more people could die from a false alarm than any earthquake that might happen. So I'm just, you know, this is a science where you've got to tread very, very carefully here, because you could very quickly just completely dismiss yourselves out of hand.
Okay, you're completely correct. It is non-linear process. And we use these parameters not like a set of different parameters, but this is a synergy between all these processes. No one can happen without another one. They depend one from another. If we observe non-linear development, like explosion when we see, and we have some threshold parameters. If you're lower than this threshold, nothing will happen. If we have higher of this threshold, and we have so-called integrate parameters which used in synergy. And if it grows rapidly, it shows that it is non-reversible profile, no way. So earthquake will happen. As concerns the reliability of our, during recent years, we made post-seismic analysis, simply detecting these anomalies. In this analysis, we had something like 80% success rate for the strong earthquakes. From the autumn of last year, we started to do perspective analysis, trying to make some kind of forecast. And from this analysis now we have half a year, we have 60% success, and it is global. And for the earthquakes with magnitude 7 and higher, we did not miss no 1.7 earthquake from the autumn till the moment. For all of them, we have prediction. We do not make it public. Probably we will be public in next YAGA conference, which will be in Cancun in Mexico. Probably we will open this result.
I want just point out one thing about L'Aquila earthquake. In my opinion, at the moment we cannot say that earthquake can be predicted. Otherwise, we would have some results, as the professor said. But we can also not say that nothing will be happen, and that's the problem from L'Aquila earthquake. Scientists said that nothing will be happened, probably pushed from.
I think we should not deviate from the topic here.
No, I was just answering about L'Aquila earthquake. So we are, as scientists, we are just trying to follow scientific method, and so try to find physical observables which can be involved in a model for making a prediction. Probably for like meteorological prediction with a kind of probability. I'm just a student and 24 years student, and I don't know what will be the future, but we are trying to follow scientific method, and I don't want to say that earthquakes cannot be predicted, but I can also not say that nothing will be happen. That's the point for me.
Phone going there. I mean, Max, if there's 100% success in prediction for magnitude 7 and above, that kind of demands, does it not, that the scientific community have some predictions that are testable in some way?
Okay, I have not seen 100% success recently, is one thing. I have not seen any trace of scientific method. I've not seen the word hypothesis. Hypothesis has to be stated clearly and then has to be tested.
Max,
So
Please again leave the scientific discussions for later.
Okay.
Have you finished answering? Yes? Okay.
The answer, and I think your question was a good one. It's very perceptive. We have to answer your questions. How many times has an anomaly also been seen when there was no earthquake? All of these questions have to be answered by statisticians.
Thank you. There was a question from Kate here.
I was just going to ask how accepted your findings have been for all of you by your peers in the field. How much opposition have you faced, and how much difficulty do you have trying to publish these findings?
For everybody?
How commonly accepted is what you're saying? If I spoke to another seismologist, would they say, how much would they agree with what you're saying?
Okay, answer. First of all, about science. We have the session of fall Conference of American Geophysical Union from 2003. So 10 years I'm the convener of the session. You can come, co-convener. You can come and see our scientific background. As concerns the founding, just here we have Valerio Tramutoli, and we had 2 years project of FP7, European Community of collaboration between the Italian Space Agency, European Space Agency and Russian Space Agency, and name of this project is Pre-Earthquakes. And we had period of the real-time monitoring in the testing areas which were Turkey, Italy and Sakhalin in Russia. We have some not very large success we have predicted few earthquakes, but still this project was funded. But from the opposite side, yes, there is double standard in publication policy, especially Journal Geophysical Research letters, which give floor more to the scientists who against the prediction than to our. So we have difficulties in publication in these journals. I stopped to submit in this journal, but I have plenty of publication. My citation index at something like 3,500. So, and according the progress of the earthquake prediction, there is no any university where the people are teach it in the earthquake prediction. And young people cannot go. What perspective we have if they know that they will be punished, that their papers will not be published? So when we say that the prediction has no future, of course, we can go in such position of seismology, we can go in infinity and have no the prediction, because the people are not teach this. This is a problem. The physics was pushed out from seismology. Now is 90% is statistical. So you have heard that we're looking on the patterns, and from these patterns we make prediction. But no physics. What happens, what physical processes are happening inside the Earth, inside the atmosphere? There is no studies. The only thing which left in seismology is seismology physical thing. They are studying the faults, the physical processes which are happening in the faults. That's all.
I think we should come back to answering the question of the journalist.
Thank you, Max.
She asked, what is the perception? And we are back to religion. There is a small group that meets every year and is agreed that all of this is gospel truth. And there is a majority of seismologists who never attend these meetings because there are these telltale figures and approaches that are not up to the standard of scientific method.
Okay, as we can see, there are divergent opinions here. We have time for one more question from a journalist, either here in the room or watching us at home. If there are no more questions, I'll thank you all for coming. Thank you to our speakers. Thank you to the journalists and to everyone else who is attending. The next press conference is the final of this year's General Assembly. It's on air quality and air pollution, and it starts at 12:15. Thank you.